Here we are at example 8 from our 8.5 set of notes. We're asked to simplify the following expression, and in just looking at this, we're seeing an operation that we're adding these two rational expressions together. What we want to go ahead and do first is go ahead and maybe swap the order of these two. So when we do that, we end up with 3x plus 1 on top still, divided by negative 2x plus 10. Typically, it's easier to have things in descending order because that kind of helps in determining maybe what a least common denominator might be. Over here, we actually pretty much just have the exact same thing. So minus 2x minus 15. Next, what we want to go ahead and do is factor things out. On top, it looks like we can't break this down at all, so he's still 3x plus 1. On the bottom, we can go ahead and pull out a negative 2 or a positive 2. In this case, we're going to go ahead and pull out a negative 2 times x minus 5 plus 1 over. Factoring this out, we end up with x minus 5 times x plus 3. And the reason why, again, we would pull out this negative 2 is because we typically like to have things in terms of like descending order for this piece, but where it doesn't have a negative exponent. And lo and behold, we even notice another x minus 5 right there. So that's kind of the strategy you want to take out with these, is factor out maybe the negatives with the highest degree, because it makes factoring things much easier later on. After that, we're going to go ahead and look at our bottoms and see what do they have in common and what do they not have in common. Over here, we notice that this piece has a negative 2, whereas this guy on the bottom right does not. So we're going to do a foo with negative 2. He already has an x minus 5. And this one just kind of has that bonus of the negative, or x plus 3. So this one's actually okay now. This one's pretty much complete. On the left rational expression, though, we have the negative 2 now. We also have the x minus 5, but it is missing this x plus 3. So we're going to do that to foo with the x plus 3 on top and the bottom. Next, we're going to go ahead and distribute these items. We have our x times 3x gives us 3x squared. X times 1 gives us positive 1x. 3 times our 3x gives us plus 9x. And 3 times our 1 gives us plus 3. On the bottom, we still have our 2 times our x minus 5 times x plus 3. And actually, that should be a negative 2. We got a little cut off, but it is a plus or a negative there. Plus, on the right side, we're going to go ahead and multiply our 1 times our negative 2, giving us then just negative 2. On the bottom, we still have that negative 2 times x minus 5 times x plus 3. After this, we're going to go ahead and combine our like terms. So there's nothing that can be combined with the x squared. So we still have our 3x squared. We have 1x plus 9x, that gives us 10x. And then we have 3 plus negative 2, so that's just positive 1. On the bottom, we still have our negative 2 times x minus 5 times x plus 3. And unfortunately, we can't really break this down any further. I mean, you could give it a shot where it's 3x and x, but it's pretty much just 1 and 1, and that's not going to total up to 10 at all. So as a result, it appears then that this would be our final simplified version. Again, though, that is example 8 from our 8.5 set of notes.